Ready? Okay. They give you a diagram. They give you the resistance. Watch the numbers of your voltmeters and your ammeters. They say one cell's EMF is 3 volts. And you must count. There's 1, 2, 3, 4, 5 cells there. So if I want to give the reading of voltmeter number 1, then immediately only have one cell and multiply by 5. 15 volts. Now, what's the total resistance? It's a total resistance, it's a parallel resistance plus the series resistance. Okay? If you want to calculate the parallel resistance, you've got to put it over 1. 1 over the total there, it's 1 over resistance 1, 2, and 3. And now you can say it's 1 over 3 plus 1 over 4 plus 1 over 6. You could have said the other way around as well, it doesn't matter. Now obviously we're going to have to find an LCM here. It's 12 is the best. 3 goes into there 4 times. 4 times 1 is 4. 4 goes there 3 times. 3 times 1 is 3. 6 goes into there 2 times. 2 times 1 is 2. Add them up, it's 9 over 3 is 3/4. Now, 1 over resistance, parallel resistance is 3 over 4. But you can't work with 1 over R, you've got to work with R. So you swap it around. To get R, simply 4 over 3. Now if you want the total resistance, you can see from the drawing, they gave you the series resistance as 8 over 3. Immediately that will give you an indication that you're going to have to work with over 3. And it's going to be easy for you because normally they choose numbers that you can work with. They don't want to test whether you can do arithmetic. They want to test whether you can work with formulas. So the total resistance here is then 4 over 3, which is the first one we did, plus 8 over 3, which is the resistance of the series one. It gives 12 over 3, which is 4 ohms. Okay? Now you know that means ohms. Now they ask you for the current of A1, ammeter 1. Now you must know that this is the formula that you're going to use for voltage and current and resistance. So it's V is equal to I over R. Therefore I is equal to V over R. Right? And we know V was last time at 15 volts. And we put that at the top. And we worked out the total resistance is 4. Divide. And we find that the amps for the first reading is 3,75. Very simple. What is the potential difference across the parallel resistors? Potential difference is also what's the voltage, right? And the EMF. So you say the voltage is equal to I times R. We know what I is now. We know what R is for the parallel resistors. It's 4 over 3. We use that one. And so the potential difference is 5 volts across the parallel resistors. So it will be this section here only for the parallel resistors. They say find the charge. Oh, you must find the charge. Now you must know, when you talk about charge, you talk about coulomb, you talk about the Q. So you say Q is equal to IT. That's the one you're going to use. Q is equal to IT. I is the current, which you know, and let's say to you for 6 minutes. And it times by 6, and then you get 6 coulombs. Okay? And 1,350 coulombs. That's your answer for charge, which is Q. Now that's not difficult. Okay?